The next presenter is Ratnangshu Das. He's from IIT-K, and his topic of talk is Trust in Child-Robot Interaction, Experimental Framework and Modeling.
Hello everyone, I'm Ratnangshu and this is our project on trust in child-robot interaction. So our main idea is, like we see in the near future, schools will be one of the primary areas where we will see robots working in unison with children. Robots will be deployed frequently. And it requires us to understand the various aspects of social interaction between robots and children. For this study, we are focusing on the trust attitude. So our aim is to understand the trust dynamics between children and robots. And then finally, we will train our robots to interact autonomously and smartly and aptly with those children. Here we have proposed an experimental paradigm with which you can study the trust attitude in child-robot interaction. And then we have put forward a computational model which can capture this trust attitude of the human participants. For the experimental paradigm, as we are considering children, we have kept a sci-fi game, which we have seen attracts the children a lot. It is a 5-round game where the child and the robot together has to travel through space. It's an adventure kind of game, and they have to interact and cooperate in order to overcome various obstacles they face during the journey. And depending on that interaction, we calculate the trust scores throughout the game, and we use this as a scale to measure the trust attitude of the children. For validation, we conducted a pilot study where we had adult subjects instead of children, and we compared the results of the trust score obtained from the game with two things. First was the classical economic games, which were used to measure trust between two adult human beings. We compared the trust score, the left figure is that. We compared the trust score obtained from the game versus the trust score from classical economic games, and we can see a decent match. So it shows that our game holds the same basic ground as the already established versions of experimental paradigm. Secondly, we posed a questionnaire set which can reveal the perceived trust of the adult subjects. They were given a set of questions and they had to mark how much they trust the robot at in every point of time. And using that, using the values obtained from that questionnaire, we computed another set of trust scores, and comparing that with the proposed experimental paradigm, we can again see a very good match between them. Thus, we consider that our science fiction game holds not only the grounds of already established games, but also the actual perceived trust of the human participants. Then we took our experimental setup and played it with children. We took the setup to a school, and there were 30 children, 30 to 35 children of the age group 8 to 11. And yeah, it was a very fascinating experience as we saw how the children were so creative and yet polite while interacting with the robots. It was overall a great experience. We played the game where the robot had 3 different strategies. First, the robot would be first in the first strategy. The robot first helped the child and then stopped helping. So we should see a gradual increase and then decrease of trust score in the first strategy. The second strategy, the robot did, but then after a certain point of time, it started helping. So here we would see a reverse of first decline of trust score, then an increase. And the third strategy, the robot always helped the children. So we should see either a gradual increase or steady high value of trust score. And as we expected, similar trust scores were obtained from the game. And then for the first strategy, where the robot first helped and then stopped helping, we compared the results of the children with adults, which we already played before. And again, we observed some fascinating differences between how they played the game. Firstly, the increase in trust score when the robot was helping, it was a sharp increase for children compared to adults. And then when the robot stopped helping, the adults we had a sudden dip in the trust score, but the children continued to maintain some level of trust towards the robot. So we can see like from the graph, the blue ones are the children and the red ones are the adults. The blue one almost lies above the red, showing that how children overall are more trusting towards robots than adults. Uh, yeah. And the second part, we finally like our final goal is to help the robot interact autonomously with the children. In order to do that, the robot should be able to anticipate the gameplay strategies of the children. So now our aim is to model the temporal trust scores obtained from the game. For this, we had three basic uh, propositions based on which we created our model. First, the trust at the current point of time always depends on the previous interactions with the robot, more so than the closest previous interaction than the farther off, which is kind of like incorporating a discount factor. Second, negative experience with the robot, like when the robot doesn't help, has much more impact than the positive ones on the overall trust score. And the third, when a higher level of risk is involved, the we add a certain risk factor to the model. Excuse me. We add a certain risk factor to the model computations in order to take into account the risk involved in higher investments in the trust game and the higher investments in the trust game. And after building this computational model based on these 3 points, we incorporated it into a cognitive architecture, the actor cognitive architecture. This is a very well established one and it holds parallel with our actual human brain. We chose it because of its simplicity in implementation and the vast scope to incorporate all the other forms of emotions as well. We just for now incorporate one factor of trust in a particular trust game, but we can increase it and integrate various different factors of trust itself into this architecture. So finally, we compared the model output with the experimental data obtained from the games. So the first one is when the adults played and the robot first helped and then stopped helping. Blue ones are the model output, red ones are the experimental data. Second is when the children played the same strategy of the robot. This is for children when the robot first didn't help and then started helping. And the third is when the children played and the robot was always helping. So in all the cases, we can see that the model is able to capture the essence of the trust score with respect to time. And in conclusion, we have uh, put forward an experimental paradigm which can effectively measure the trust score in child-robot interaction. And then we have proposed a very simple model which can capture the trust attitudes with respect to time for different groups of human participants. Next, what we are planning to do first is like update the game from a physical experimental paradigm to an online game. So we can first of all try check out the effect of embodiment of robots intelligence, and also we can gather a much larger database of the experiment. Second, as I mentioned before, we use the actor cognitive architecture to implement only one trust factor in a specific game. But the actor holds a potential to incorporate a much larger set of emotions, and that we will surely explore and integrate and make the robot as emotionally aware as possible. And thirdly, that this point we're currently working on, we are building a reinforcement learning framework and training the robot to play the game intelligently and seeing like what is the optimal strategy of the robot, like to help or not help during the course of the game. And yeah, thank you.
Thank you, Ratnangshu, for your nice presentation. So from audience, if you have any question, you can raise. Okay, I have a question. Is what is trust core, and how in the experiment you get those values?
So this we develop science fiction game. As I mentioned, the robot and the human would be traveling in space. They will face an obstacle and they have to overcome an obstacle. So here we have incorporated this science fiction energy currency called energy cells, which the children will give to the robot. The robot will take the cell and then decide whether like to trust, to help or not help. And these cells that the children can give any number of cells to the robot, which would actually indicate how much trust they have towards the robot. We have added value of the cell towards the children as well, and yeah, that's how we calculate the trust score.
Okay. Okay. Thank you very much for your nice reply. So from audience, if you have anything.
I have a question. So you are using trust-based algorithm, right?
Sorry?
You are using trust-based teaching algorithm, right?
Yeah.
So what's the difference between reinforcement learning? Because the same things, so far I know, you can also apply this type of technique. So what do you think about it? It's just my curiosity.
In this future work using reinforcement learning, why we are using it.
Oh, okay. Thank you. I got it. I was expecting something like that. Okay, thank you.
Okay. Do we have any other questions from audience? Okay, Ratnangshu, thank you once again for your nice presentation and explanation.